Alright, this is what I bought right here. This is a fan controller for a PC. It's designed to go into a 3.5-inch drive bay right here, and then they give you some screws and you just attach it like a regular drive. So what I'm going to do is use this and replace that with what I came up with over here, which is this whole arrangement. I was going to keep this and this, the power and the switch, but and take this potentiometer out and everything that was connected in here and wire this in there. I decided not to do that, and the various reasons. The main one was that excuse me, let me put this back. The main reason was that I needed 12 volts, plus 12 volts, and plus 5 volts. Because this isn't a computer, it has that already. And this is the, let me just show you the front real quick. Speed controllers right here. That's pretty simple. As soon as you plug it in, it comes on. There's no on-off switch or anything. And then you have an RPM gauge that's backlit. And it gets those signals from here. Okay, so in this case, the black is negative, the red is positive, and the yellow is the tax signal. Okay, regular 3-pin for a muffin fan, for a PC. Here's the power though. And this is what the problem I ran into. It uses the regular standard PC Molex connector that you would have on a drive. So you have plus 12, plus 5 volts, and then grounds. So I can no longer use this power supply because all this puts out is 12 volts. And it's barely, it probably doesn't have this, it's got 850 milliamps. It may be enough to run it. The fan's going to take 630 of it. And then of course this circuit. So I'm going to do away with this and just use this setup like I originally intended for here. Maybe just on-off switch and power, and just do away with this and use this on another fan. And just do away with this idea and just use it as an on-off switch. So, but I'm going to switch this out off of this fan, just completely start over again. This was just kind of fashion some ideas, and I knew this wasn't going to work with the, as far as the stalling out after it gets past its cutoff voltage. So that's that. This works great. It's pretty simple. It's not very expensive. It's $10. Local computer store. If you're concerned about wiring it up, because all fans are a little bit different depending on the manufacturer, it has the wiring output voltages and the color codes on the PC board. So like on the power, it's the yellow is plus 12, you have 2 grounds, and then the plus 5 is red. That's standard PC stuff. And then the ground on here is the black wire, and then the plus voltage is the red wire, and then the in signal or whatever is the yellow. That's the tax signal from the fan. Like kind of like modern cars have the pickup. I think they call it reluctor ring or something like that. It's a pickup that's on the crank or whatever, so it knows the speed of the engine, I guess, for the timing of the spark and all that. So that's that. I'll wire it up in a second. The other thing I picked up when I was there, and this is for no other reason, just that it's cool, is a temperature gauge. Runs exactly the same off of a Molex. You just plug it in. All it uses is 5 volts. So you can run it. It's got a Celsius. So right now it says 21.2 Celsius, and then you press it again and it goes back to Fahrenheit. And it's got a bar graph up here on the top, and just a standard numeric on the bottom. And then here's the sensor. It says it's very flat. So I would imagine it's designed to go in and around a CPU or whatever you want it to, and you can just kind of attach it somehow, either by pressing on it in between two surfaces, or see it's already gone up to 95. It's pretty sensitive. It's been out here on, just measuring the air temperature. I don't know how accurate it is. Probably it has a little bit of, probably only designed to really work in a PC application, but where it actually makes contact with the surface, it's measuring the temperature. Okay, so I've got some aluminum sheet. I'm just going to fashion something off of this and just attach this. So I have, this is identical fan that's in my stove, and I had to cut it out, unfortunately, to use it as for the spacer. So I had this one, and I cut the end off, and now I have where'd it go? You know, it's staring at me here. Here it is. I cut the end off because I don't want to cut the end off of this stuff out of here. Too many wires. I don't want to cut the end off of this. So I'm just going to plug this in and then be able to unplug it whenever I need to switch out a fan. Now I've already cut the end off of this one and hardwired it in, so I'll be able to just solder those wires on here and have this connector. And then I've got some shrink tubing, just gonna finish it off. So for this example, I'm using this fan. It's another fan that I have. I have 3 classes of fans that I had. This is a fan that was on the CPU, so it was on a Pentium 4. This was in front of the cooler, so that's that fan. And then these fans were in the case. Sorry, these fans were in the case. And then I had a power supply fan, which is similar to this. Let me get to this real quick. I forgot about this. Basically, this is a power supply out of ATX computer, and the wiring diagrams are on the side here. To get it to work in this, it had 2 outputs for the drive, so I've cut one set off of here just to have one, and then I have another over here that I did the same. I cut the other set off because they have the different drive. They have other drive cables on there. And then of course you have I forgot what it's called, but there's an external 12 volt for extra power for like some motherboards use it, and some, I guess, video cards. So this is just 12 volts. And then this is these are the outputs for the motherboard, which have all kinds of different, like 3.3 voltages and stuff like that. And this, I didn't remember what this was. But I just cut the end off. I wasn't using it even in the computer it was in, so some auxiliary thing. To get this to work, because it has an on-off switch in the back, it's got one that's actually right here, but this is essentially off of the motherboard on an ATX power computer. This is the power switch, so you need to take the green wire and just ground it out. So just pick a black wire and connect it if you're going to use it. But I always refer to the side. See, it says PS, power supply on, green, and then black is common. So, and this is the power light, I think, the gray, for the case. So since I had to switch it up and add the extra 5 volts that I wasn't used to with that power supply, I decided just to use a computer fan. It's even less practical than this application, and I may get an actual power supply that can actually put out a couple amps. I actually have a 3 amp power supply that's designed to be for automotive use. You know, you can run anything that's automotive by plugging in either the cigarette lighter attachment or just attaching the wires, hardwiring it in. and then it converts it to 12 volts. So I could use that and just go with the 7805 5-volt converter circuit and just then break down to 5 volts off of there, and then to get my power. But this is just, you know, for at the house, this is just as convenient. None of them are going to work out in the field, so to speak, with anything. If you want to actually take this and use it out in the field, you know, it's not that practical. And let's see what here. I added that. I didn't have a fan cover, so I got a fan. This will go on down there to cover it up, because I've already got my fingers in there once. So about that. And I got a big muffin fan for the top. And I'll probably make something that lifts it up a little bit, and just use this channel to catch whatever it is. Probably just put on a nut and a bolt and just let it get caught in here or something. You have to be able to take it on and off to add fuel, so you can't just attach a hard connector. Okay, so now let's get to the good stuff. The unit has a amongst other things, it's got right here. This is a let you know if your fan, basically if it stops reading a tach signal, it'll let this fan, it'll let you know that your fan stops spinning, and audibly let you know. So if you're in a situation where you're actually relying on it to cool your computer, then that's what that will do. Let me connect up. Oh, I didn't get to this. There's one more thing on the fans. If you notice, these are 4 wires on here. So you have the black and the yellow, the green, and then the blue. The blue is not being used. The blue is for pulse width modulation. So you're giving it 12 volts all the time, and you're pulsing that 12 volts on and off through the fan itself. The tach is the other one, the green, and then the positive negative is the yellow and black. So it happened to line up and work perfectly on here, but when I switched it up and used it onto this fan, it didn't seem to work. And it could have been because when you unplug a fan and it's not getting, and it starts to make the beeping sound, it's possible that the fan was, the controller wasn't putting out power when I plugged in, because I was switching this one out with this one, and this one didn't spin. So, but I got it to spin by just rewiring it with this. So it could be just the wiring, or it could just be that this controller shut the power off and wasn't going to let it spin until you reset the alarm sound. So let me put this down here real quick. Plug this in. Make sure it's connected right. Okay. And I will plug it into my other connector. Okay. Now this is down all the way. You can see the display. It says 2250, and it goes back and forth. And the fan is here spinning. Oops. Probably going to move around a little bit, but try to get them both in the shot. Okay, so now you just move the fan up. Now this is about 40%, and it's running at 4,030 RPMs. And the fan's making more RPM over there. I think that'll work. Now going up to about 60, which is about 4860 or 4830. That's 80%. It's taking off like an airplane. Let me just put it upside down. Okay, yeah, be right back. Now we're about 5380. That's 80%. Now we're at max, which is 5280. So basically 5,000 plus RPM. You can see the yeah, see, I just stopped the fan with my hand on accident. That's a good that happens. See, it's making the beeping sound because it's not getting the signal, but what I ended up doing, I think, is just jamming the fan blade into Yeah, it did. Let me unplug it. Yeah, I did. I hit the fan into my hand. I think that's the end of this fan. It's kind of a cheap fan, but anyways, you get the idea. So that's kind of what happens. As soon as this stops getting a signal on the yellow wire, it'll start beeping. So anyways, it's working, but I'm not going to plug it back up in again. So yeah, so that's a pretty cool idea. It works good. It goes through the full range RPMs. Now, of course, it's running a low range, and it will stay there. Similar to what was going on here, I was trying to get it to go from pretty much off to all the way up, but eventually it's gonna get past a certain voltage and it just shut off. But these run in a computer. You always want the fan going at some point. So this is designed to go from around 3 to 5, so you got about 3,000 RPM difference. So that was I was wishing I could get it to go from an even lower RPM up, and that could just be this fan, how it operates. I don't know if each fan's different as far as the RPM that it will be at as far as idle and what its maximum is, or is it based on this? I have to experiment some more. So, but eventually I'll get this set up and I'll reattach. I'll fashion it on here somehow. Get rid of this. I'll keep it for something else. This worked for a couple days or whatever, 2-3 days. It was enough for my needs just to get some ideas going. And I'm glad that I had this as an idea, because this would work really good. And it's good that I have at least some control over it versus, and I don't have to worry about it stalling out. So, but I really would like to see that this, would go from maybe like 1,000 RPMs or 800 RPMs, and then go up. I don't even care if it goes up 5,000. I just, get it to where when I start this off, give it time for it to take off, and then when it gets to the point where it's starting to get to the bottom and exposing more of these holes, what ends up happening is the ash starts blowing up into it, and then of course that ash is hot, and it rains down, kind of goes everywhere. So kind of slow it down a little bit, because when it gets to that point, it's pretty much done. There's no more fuel in there. It's just embers, and those embers are just breaking apart. And as long as you blow on them with air, of course they're going to glow and produce heat and stuff until they're completely gone. But to have some control over it would be a lot better than having to just unplug it and lose about 5 minutes of usable heat and stuff. So okay, well, that pretty much does it. I'm going to work on this. So look for the new video. And in buying this, I really didn't have any ideas other than just I saw it on the website when I was looking for controllers, and I happened to go to Micro Center. In California we have Micro Center, Fry's. I mean, I don't think Radio Shack has this kind of stuff. They have temperature gauges, but they don't have speed controllers, so I didn't think I looked there. And maybe you might come across a handful of hobbyist type electronic stores where they have a lot of old used equipment and mixed in with some new stuff that they're selling. A lot of the electronic stores over here. We have one called JK Electronics. They have they focus mainly on audio, and they have a lot of electronic components. We had one also called, I think, Orvac, which was in Fullerton, and one called Save-On, which I think actually went away. And then down the street from where I work, there's a whole string of electronic stores. So there's no shortage of places to look for cool gadgets and things for, adding them to like these fans or these stoves with the fans and stuff. But I had no real use for this other than just it was cool, and it wasn't that much. So it was like $13. It was a little bit more than this controller down here, but I can probably, maybe I can work this in somewhere down here you know, measure the temperature in the fan area. You know, I don't know if I don't want to keep it in there. I want to use it for other uses instead of going back and forth with the measuring the temperatures. I would just be able to read the actual temperature in this chamber or whatever that's under here, just to make sure that nothing's falling in there. Is that, you know, just to keep an eye on it. But then again, I don't want to burn this. So. This is just a thin piece of film with looks like a thermistor of some type in there, thermal resistor that they shrink wrapped it onto the wires. Anyways, so the next thing I want to do once I get all this fashioned up and working, right now I'm just going to get it kind of put together and get something going, check it out for operation, and then when I get it working I'm going to build something to replace this power supply and just focus on getting 12 volts into the circuit, and I'll section that, you know, I'll separate that 12 volts down, step it down to 5 volts. So I just don't know how sensitive this is to voltage levels, and you know, this power supply is probably not very clean as far as its intended use. Where this is expecting to see something in a computer, where I'm sure these have a certain amount of specs as far as voltage, and this is just a standard switching power supply, but you know, it's like it's got you know, chokes and coils and capacitors and all kinds of stuff in there, fancy stuff, to make sure that it's putting out the correct clean signal. So alright, so there you go. That's my idea. If you decide to try anything like this, experiment, make sure you know what wires do what. Every fan is going to be, you know, manufacturer might be different, and power supplies, like I said, they could be different as far as the actual, you know, some might have used their own, this is pretty standard. They might have their own proprietary stuff, or even if they're using the right colored wires and the voltages, their connector on the end could have the wires in a different pinout position or something. I don't know. As far as this goes, this is standard. Every drive you buy, it's going to accept the power off of one of these. So you can see on here the same color codes that are on here. So, okie doke. I'll catch you guys on the next one.